There is a building material that gets stronger over decades, and the government made growing it punishable by prison. French researchers documented 300-year-old hemp walls still gaining structural integrity. No steel reinforcement, no chemical additives, no maintenance cycles. Compressed plant fiber and mineral binder. Walls that repair their own stress fractures. Hemp cultivation traces back 10,000 years in China, where it was used not just for textiles but as a fundamental building material. The Romans utilized hemp fiber extensively in their ships, the ropes, the caulking, even the sails. It was literally the fiber that held together the naval empire that dominated the ancient world. What's less known is that medieval European castles incorporated hemp lime mortar in their foundation work. Some of these structures have stood for centuries, their walls becoming stronger with each passing decade. By the 16th century, English law actually required farmers to grow hemp. It was considered so essential for naval supplies that refusing to grow it was unpatriotic. In early America, hemp wasn't just common, it was foundational. George Washington and Thomas Jefferson both cultivated hemp extensively on their plantations. By the 1850s, Kentucky alone produced 40,000 tons annually, making it the largest hemp producer globally. The covered wagons that carried families westward used hemp canvas. During the Civil War, both Union and Confederate forces depended heavily on hemp rope and textiles for their military operations. The physics behind hemp's remarkable properties is straightforward but profound. Hemp fiber contains approximately 70% cellulose, essentially natural polymer chains. When mixed with lime mortar, it creates an alkaline environment that preserves this cellulose indefinitely. The resulting fiber matrix composite distributes stress loads across the entire wall surface. Most remarkably, the material becomes denser and stronger through a natural carbonation process that continues for centuries. But something happened to this miracle-building material in the 20th century. The 1937 Marijuana Tax Act effectively criminalized hemp cultivation, despite industrial hemp containing less than 0.3% THC, far too little for any psychoactive effect. The legislation imposed a $100 tax per ounce, making hemp economically unviable overnight. This wasn't coincidental. It happened just as DuPont secured patents for nylon and other synthetic fibers. Meanwhile, William Randolph Hearst's newspaper empire aggressively promoted reefer madness hysteria, conveniently protecting his vast timber holdings used for paper production. There was a brief revival during World War II when the government launched the Hemp for Victory campaign, encouraging farmers to plant over 400,000 acres. The military desperately needed 34,000 tons of hemp fiber for parachutes, rope, and other essential war materials. But as soon as the war ended, prohibition immediately resumed with even harsher penalties. The 1970 Controlled Substances Act dealt the final blow, classifying hemp as a Schedule I narcotic alongside heroin, making no distinction between industrial hemp and psychoactive cannabis. From that point forward, growing this building material became a federal crime carrying up to 5 years in prison. As hemp disappeared, a replacement system emerged. The concrete industry grew to $37 billion annually by the 1970s. Steel reinforcement, Portland cement, and chemical additives became the new standard. Building codes were written around petroleum-based materials and processes. The knowledge of hemp construction simply vanished from architecture schools and building practices. The legal barriers were particularly effective. Federal felony charges for cultivation kept farmers away. The DEA conducted raids on university research programs through the 1990s. Import restrictions made hemp building materials virtually unavailable. A building technology used for millennia was effectively erased from American construction in less than a century. But the science didn't disappear, and research continued outside the United States. Modern laboratory testing at the University of Bath has shown that hemp lime blocks achieve 0.5 to 1.0 megapascals compressive strength. And remarkably, this increases 15 to 20% annually for the first decade through continued carbonation. The French National Institute has documented 300-year-old samples that are still gaining structural integrity. Perhaps most impressive is the zero degradation observed in walls exposed to moisture cycles for centuries. The performance comparisons with conventional materials are striking. Standard concrete achieves 25 to 40 megapascals compressive strength but begins degrading after about 50 years. Hemp lime, by contrast, is self-healing through lime carbonation and improves with age. The thermal performance is equally impressive, R 2.5 per inch for hemp lime versus a mere R 0.08 for concrete. And while concrete production releases approximately 400 kilograms of CO2 per cubic meter, hemp lime construction actually sequesters 165 kilograms of CO2 per cubic meter, making it carbon negative. The material's resistance properties are equally remarkable. The lime creates a pH 12+ environment that's naturally antimicrobial. Insects cannot digest cellulose in this alkaline matrix. Fire testing shows 2-hour burn resistance without any chemical treatments, and there's no off-gassing of toxic fumes during combustion. Structural engineering data reveals flexural strength superior to unreinforced concrete in earthquake testing. The self-repairing microcracks through ongoing lime carbonation maintain structural integrity. The material is vapor permeable, preventing moisture accumulation and mold growth. It maintains dimensional stability across temperature ranges from -40 degrees Fahrenheit to 120 degrees Fahrenheit. While America maintained its prohibition, Europe began rediscovering this ancient building technology. France legalized industrial hemp cultivation in the 1990s, leading to over 10,000 hemp lime buildings constructed since 2000. The UK established the Hemp Lime Construction Association to develop building standards. The Netherlands began incorporating Hempcrete in social housing projects. North American pioneers worked against significant obstacles. Steve Allen built the first permitted hemp house in the UK and meticulously documented the process. Chris Magwood constructed the Flemington Health Centre, the first hemp building in Canada. Colorado State University established a hemp research program after the state's 2014 legalization. Kentucky farmers, long known for tobacco production, began transitioning their fields to industrial hemp. Today, we're seeing remarkable applications globally. The Adidas headquarters in Germany features hemp lime insulation throughout. Social housing projects in France use 100% hemp lime construction. The Canadian military is testing hemp lime for blast-resistant structures. Australian communities rebuilding after devastating bushfires are incorporating hemp lime for its fire resistance. The movement is growing. The 2018 Farm Bill finally legalized industrial hemp cultivation in all 50 states. The Hemp Building Association has formed to develop North American standards. University research programs are now studying optimal mix ratios. Architects are beginning to specify hemp lime in sustainable building projects. So how does hemp lime construction actually work? The process is surprisingly straightforward. Hemp herds, the woody core, are mixed with lime binder and water. This mixture is either cast in forms or hand-packed between timber frame walls. It cures through carbonation, literally absorbing CO2 from the atmosphere. The timber frame carries structural loads while the hemp provides insulation and thermal mass. The materials and ratios are simple. Hemp herds cost approximately $200 to $300 per ton and are essentially an agricultural waste product. Hydraulic lime runs $200 to $300 per ton and are essentially an agricultural waste product. Hydraulic lime runs $400 to $600 per ton. This is natural limestone, not Portland cement. The water should be clean and non-chlorinated for optimal carbonation. A typical ratio is 1 part lime, 2 parts hemp herds, 1.5 parts water. The construction process begins with erecting a timber frame, which carries all structural loads. The hemp lime is mixed in a mechanical mixer or by hand, then packed in 18-inch lifts, with each section allowed to cure 24 to 48 hours. Final wall thickness is typically 8 to 12 inches for optimal thermal performance. Cost analysis shows materials running 8 to 12 per square foot of wall area, compared to 8 to 12 per square foot of wall area, compared to 15 to 25 for conventional insulated walls. Labor costs can be significantly reduced, as the system can be owner-built with basic training. But the most dramatic difference is lifespan. Hemp lime walls have been documented to last 300 plus years versus 50 to 100 years for conventional construction. The historical continuity is striking. George Washington grew hemp at Mount Vernon 250 years ago. French masons perfected hemp lime technique in the 1700s. The fundamental physics hasn't changed. Cellulose and lime still bond permanently. Modern testing has simply confirmed what medieval builders already knew. The reality of suppression is equally clear. We've experienced 80 years of federal prohibition over a plant with less than 0.3% psychoactive compounds. A $37 billion concrete industry has been protected by laws written for entirely different purposes. A building material that actively absorbs carbon was classified as a dangerous drug. Farmers were imprisoned for growing a construction material used successfully for millennia. But now we're seeing a genuine opportunity. The 2018 legalization has opened the path to hemp building materials. The climate crisis demands carbon-negative construction methods. The housing affordability crisis needs lower-cost building systems. And hemp grows successfully in all 50 states, eliminating import dependency. The simple truth is this: every home built with conventional materials was designed to eventually need replacement. Hemp-lime walls, by contrast, get stronger for centuries without maintenance. One crop produces bulletproof, fireproof, pest-proof building blocks. The knowledge was never lost. It was just made illegal to use. What shocked you most about hemp suppression? Tell us in the comments what ancient building technique you want us to uncover next. Hit subscribe now. Join the movement rescuing lost knowledge before it vanishes forever.